Hi everyone, let's solve another Leetcode problem. And today's problem is problem 1478, allocate mailboxes. This is categorized as a hard problem. Let's see how we can solve this. So first, the problem statement, we're given an array houses, and this array, the value in this array indicate the location of different houses, okay? And you can think this location indicates the location along a straight line. And then the second input that we get is a value, integer value. This is the number of, this value indicates the number of mailboxes. So the problem is we have to allocate these mailboxes to these houses so that the distance to the mailboxes is minimized. Okay, so for example, you can see in the first example, we're given 5 houses. The locations are like 1, 4, 8, 10, and 20. And then we are given like 3 mailboxes. Okay, and the best way, one of the optimized way to allocate these mailboxes are putting them in locations 3, 9, and 20. And that way you see the distance from the houses and to the mailboxes are minimized, because the distance here is 2 from the first house. From the second house, the minimum distance to the mailbox is 1, and similarly this is 1 and 1, so in total the distance is 5. Okay, if we put the mailboxes somewhere else, it might not be minimized. Okay, and for the next one, you see we are given the location of 5 houses, right? And we are given like 2 mailboxes. So if we put the mailboxes here and here, each house will, the distance from the mailbox to each house is actually minimized. To solve this problem, we need actually 2 insights. So first insight, and these are like very important insights or observations. For the first observation, let me first draw some houses and some mailboxes. So for the ease, I will put, say, rectangles for houses and say this, or circle for mailboxes. Okay. So let's say we have, say we have 8 houses. Okay. We have 8 houses. And then we have just one mailbox. One mailbox. So where do we put this mailbox? The thing is, we put it in the median house. So they say the location is here 0, and then this is 2, this is 5, this is 6, and then let's put this 12, this is say 14, 15, and say 17. Okay, so these are the location. And we have to put one mailbox. So let's put the mailbox here. And that is the optimized distance. Now your question might be how this is optimized. Okay, so let's see how much distance it carries. So from this one has a distance, this house has a distance of say 6. This has a distance of 4, right? This has a distance of 1. This has a distance of 0. Okay, this house has a distance of 6. This one 8, 9, and this is 11. Okay, so this is the total distance. Now let's say if I put, you say you think, okay, let me put the mailbox instead like in a middle position, or instead of middle, let's just move it one place. So if I put the mailbox here in 7, so how much gain we make? You see that this mailbox is now nearer to all these houses, right? So we get a gain of, say, the distance is minimized by 4. Okay, so it's less for distance. But here you see that each one actually has now more distance. So in total there is like plus 4, additional 4 distance has been added. So if I just add these two, it's minimized, right? they actually cross each other. So there is no value of putting like moving this mailbox to one step to the right. Okay. So instead, let's do one thing. Let's move one step to the left. Now let's see how much gain or how much we lose. You see the all these five houses now have additional distance of say 5, right? And these three houses actually gained. They now have lesser distance to the mailbox, and they have like 1, 2, 3. So each of them have like one less distance. So previously it was 6, now it will be 5, it will be 3, and this is going to be 0. Okay. So in total, you see we have like gained, we haven't gained anything because we are trying to minimize the distance, but now we are actually increasing the distance by moving it to the left. So you see, if I don't put the mailbox at the median house, if I put the mailbox in the median house, in the worst case, moving it to the right actually gives me the same minimized distance, or moving it to the left or right, it may even become worse. We do not gain anything. So this is the first thing. Observation 1, put the mailbox in the median house. Okay, in the median house. Now, if you look at the problem itself, the picture that was put in the problem, that's a little bit misleading. You see here that this mailbox is not put, so we have like a three mailboxes, right? So you see that these mailboxes in some cases are not put at the houses. Instead, it's put in the middle. Well, in the middle, it's not always bad. So as you have seen that if we had moved the mailbox here, right, it was fine, but we wouldn't have gained anything. So the same thing here, if I just had put the mailbox, let's say instead of here, and instead of here, if I had put the mailbox to one of the houses. So let's say median of these two houses is, what is the median of these two houses? Any of the houses, right? Because there are just two. So median of two is just any of the houses. If I put the mailbox here, you see my distance from here is like 0, and distance from here is like uh, uh yeah, if I put the mailbox here, and distance to the mailbox to this house is like 3. Okay, so it's 3. So 0 plus 3 is 3 here for this cluster. Instead, if I put the mailbox in the middle, still it's 2 plus 1 is 3, right? Okay, so that means that instead of just putting the mailbox here, why don't we follow the same thing? We always put the mailbox in the median house, right? The median house might be this or this. Still, we get the distance of 3. Okay, so for the second one, you see we had like 1 plus 1 distance of 2. So instead of just putting the mailbox here, we follow the same policy. We put the mailbox in the median house. So if I put the mailbox in the median house, either we put it here or we put it here. So if I put the mailbox here, the circle, right? The distance here is like 0 from the house, and the distance here is 2, right? So 0 plus 2 is 2. So still we get the same thing, right? Okay, so there goes our first observation, that put the mailbox in the median house. That will minimize the distance. The second thing, how do we solve this? That is the insight number 2. Insight 2 says like make the cluster of houses and then assign one mailbox to each. That is actually quite intuitive. So you see here that we have like 3 mailboxes, and we also have like 3 clusters. So we don't have a proof yet, but we can say that putting the mailboxes in each cluster actually minimizes it. Let me show you one picture again. So let's see, we have the houses here. Okay, so one here, and then Yeah. And then we have one here, and then we have one here, one here, and then, so these are the houses. Okay. And then let's say we have, say 4 mailboxes we have to assign, right? So why don't we just make clusters, very, like, let's say one cluster here, one here, and then we can make one cluster here, and then one cluster here, right? So putting this probably will give us help us minimizing the distance from the mailboxes. So we put the mailboxes in the median houses. So we put one mailbox here, right? For this one, the median house is either this or this. Oh, sorry, for the second cluster, this cluster, we put the mailbox, say here. This is the median house. For this one, if we have just 2 houses, any of the houses is median, right? So we put it in the left. And for this one, we put it in the median house. So we are always putting it in the left. Okay, we put it here. Similarly, this one here. Okay, so this is like our optimized thing. Now, how do we do this thing? So we got our second insight. So the second insight is cluster the houses, like make groups, and then assign mailboxes. Okay, so how do we solve this problem? So let's draw this more formally. Say we have these houses. Say we have, say, n houses. Okay, n houses, and we have k mailboxes. So what we do is we actually try to, say, first make a group of 1 and assign 1 mailbox. And then for the rest, we make another group and assign k minus 1 mailbox there. So basically, we are trying to solve it in a brute force manner. That means trying to create all sort of groups, right? And then what we can do is we can just make this group bigger. Like, let's say we make this group bigger, 2 houses, right? And then 1 mailbox here, and n minus 2 houses, and k minus 1 mailbox here, right? Next, we can try with the other group, like let's make it even bigger, 3 houses. We take the first 3 houses and try to put 1 mailbox there in an optimized way in the median house, and then we take the rest, n minus 3 houses, and put k minus 1 mailboxes there. So you can see we are trying to create all sort of groups. Now, recursive, we are actually doing some kind of recursion. You can see that here. We are doing it recursively. So if you just look at this part of the problem, so now you see we have like n minus 3 houses and k minus 1 mailboxes. So this is n minus 3 houses and k minus 1 mailboxes. So why don't we just do the same solution here? So this is the sub problem, right? So we do the same thing here. So we take 1 house here, right? 1 house, 1 mailbox. And then for the rest, what is the rest? Is n minus, say, it was n minus 3 houses, right? So we took 1 here and n minus 4 houses and k minus 2 mailboxes. You see that? So we recursively break it further down. Okay, so there goes our insight. Now, okay, so let's formally define the recursion. We have n houses, and we have to assign k mailboxes to these houses so that the distance is minimized. So we can define the whole problem using 3 indices. The starting house of the group, the end house of the group, and the number of mailboxes to be assigned. So the whole problem is going to be this, right? Where the starting house is index 0 house. Since we have n houses, n minus 1 is a end index, and the number of mailboxes to be assigned is k. Now we can start creating smaller groups. So we create a group of 1 and assign 1 mailbox, and for the rest n minus 1 houses, we assign k minus 1 mailbox. So you see, this is now broken into 2 problems, right? Or we can make a group of 2 and then group of n minus 2, right? Okay. Or we can make a group of 3 and make another group of n minus 3, right? Okay, so as you can see, finally what we have to do is we have to take the minimum of this, right? Now look at these subproblems. Each of these subproblems actually can be broken into further smaller subproblem or further groups, right? So this one, there are like n minus 1 houses here and k minus 1. So we can also break it down into 1 house and 1 mailbox plus n minus 2 house and k minus 2 mailboxes. Okay, yeah, so if we look at it as a tree, let's see how it looks like. Say we have 8 houses, index 0 to index 7, and we have 4 mailboxes to assign. So we can create smaller groups. So we can create something like this, where we have like n one house and then n minus 1 house, right? Or we can have like 2 houses and n minus 2 houses here, or we can have like 3 houses and n minus 3 houses, right? Okay, so you can see that, and then we can have like further other groups, right? Okay. Now let's look at this one. Say we see that there are 2 houses and we have to assign 1 mailbox here, and then the rest of the houses from index 2 to 7 are here, and we have to assign 3 mailboxes, right? If we further break it down, it will be even a smaller problem. So this is one of the ways to break. This is another way, and there are also other ways to break. Now let's take a look at this one, how we break this, right? So we have to, from index 2 to index 7, there are like 6 houses, and we have to assign 3 mailboxes. So we can say that, okay, let's make a group of first 3 houses and assign 1 mailbox to them, and then make another group of the last 3 houses and assign 2 mailboxes to them. Okay, so let's focus on this one. Similarly, let's break this problem down. Here we have like 5 houses and we have to assign 3 mailboxes. So we make a group of, say, first 2 houses and then last 2 houses. For the first 2 houses, we have 1 mailbox, and for the last 2 houses, we have 2 mailboxes. So if you clearly note, like observe here, you can see that these 2 subproblems are actually the same, right? So basically, when you're actually doing brute force with recursion, we are hitting the same subproblem. So instead of solving these separately, obviously what we want to do is we want to optimize it. We can keep a memory, or this is the memorization technique that we are going to use. So we can keep an array where these will actually be identified by the start index and the end index of the group, start index of the group, end index of the group, and how many mailboxes that we want to uh, assign to this group. Okay, so this is the dimension uh, of the cache or the memory array. Okay, so taking a look at the code, you see we have 2 integer. One is integer n denotes the number of houses, and this is the memory for memorization, or this is for the cache, and this is 3-dimensional, right? So we define it with number of houses because we have n starting indices, n end indices, and then we have k mailboxes. But we keep the dimension as k plus 1 because for we want one mailbox to be defined by index 1, not by index 0. That's when we are just adding one more. And then we are filling up these memory array with -1s. And we have a helper function. In the helper function, we actually create the groups. So initially, the group is going to be from index 0 to index n-1, and we have to assign k mailboxes. Okay, so let's see how the helper function works. So at certain point, if the start index goes to n, that is means we have exhausted all the houses. In that case, we return 0. This is a base case. Otherwise, we first check if this recursion state has already been explored in the past. In that case, it will no longer have a value of -1. And if that is the case, we just return it. We don't do the breakdowns of the groups and other things. And this is the important case where we have to assign just one mailbox. Now we have the start of the group, end of the group, and we have to just assign one mailbox. And as we had discussed, we have to assign this to the median house, right? So what we do is we call this function. I have created another function to calculate the median location of the house and calculate the distances from other houses. So what we take is I take the median and median index, and this is the location of the house, right? So this is the median location, and then I calculate the distance, the difference of distance from each house in the group to that median location house, and finally I return it, right? Okay, so if we have like just one mailbox to assign, I just call this, assign this to the obviously to the cache or memory, and then return this. Okay, so that's the important case. Otherwise, we have to start breaking the groups, right? And we have to keep track of the distance and take the minimum distance. So what we do is we start breaking the groups. So the group is from start to end. So initially we make a group of say 1, right? And by this end 1, I mean the end index of first group. So first we obviously the end 1 is going to be the start. So that means this group is going to be just of size 1. So what I am doing is I'm calling this get min distance. So for the first group, I am just assigning one mailbox, right? So this is the function for one mailbox. And then for the rest k minus 1 mailboxes, I am just calling this function recursively again. Next step, in the next iteration of the for loop, I am assigning one mailbox for the first 2 houses, and then for the rest, I'm assigning k minus 1, right? And we'll keep on doing this, and every time we get the result, we compare with the previous mean distance. This way, we will actually get the minimum distance for assigning k houses to this group, right? Okay, and finally we assign that mean distance value to the memory and return it. Okay, so that is it. That is what the helper function does, and we call this helper function for the whole n houses with k mailboxes. Okay, so next let's take what's the time complexity. So as you can see, this was our problem, and the problem had like 3 dimensions. One is the start index, or 3 parameters, end index and the mailboxes. So we can have n start indices, n end indices, and k mailboxes, right? So in total, there are like how many recursion sub problems we have? Like we have n square into k. So n square into k total states. And as you can see in each of these sub problems that we are solving here, right? We actually run a for loop of size n. That means in each state, we are running n operations. So if we just multiply this, we have n cube k. That is the time complexity of this algorithm. And the space complexity, we have a memory of, you see, it's a 3-dimensional memory. And this is the start index, this is the end index, and this is the number of mailboxes. So in total, we have like n square into k memory in the size of the array is n square into k. So the space complexity is the order of n square k. So that's it. I hope you now understood the problem and you can now solve the problem yourself. We'll meet for another problem next time. Thank you very much.